Hello, I'm KOWEL.
And I'm KRINA.
Our project is gesture control mouse using IMU and flex sensors.
It uses hand gestures to control mouse movements and actions. We applied concepts from sensor interfacing, signal processing, and data communication to make this possible.
Let's move on to show how it works. Through this project, we aim to improve the accessibility and comfort of traditional input devices like mice and touchpads, which require precise hand movement. These can be challenging for users with mobility issues and those having repetitive strain injuries. As hands-free control become very crucial in areas like self-service system, medical equipment, and VR and AR, we are developing a gesture control mouse using IMU and flex sensors in a glove, offering an intuitive, low effort alternative to computer
Here's the
mouse.
setup.
Let's have an overview of our system. Our system is a gesture control mouse that works without physical contact. Now here we have used an MPU6050 sensor that detects the wrist rotation, and we have used two flex sensors, one on the index finger which detects the left click and one on the middle finger which triggers the right click. Then we have used an Arduino Uno that sends the sensor data to the computer via USB cable.
The MPU6050 sensor is connected to the Arduino using the I2C protocol. The SDA goes to pin A4, the SCL goes to pin A5, and it is powered by the Arduino itself with 5 watts VCC and grounded accordingly. Further, the flex sensors, as you can see on the other side of the glove, are connected to the analog A0 and A1 pins of the Arduino, and the other leg of the flex sensors are connected to a 10 kilo ohm resistor which is grounded. What this basically does is it keeps the readings very stable and avoids random noises when the sensors are in building. The Arduino is powered by a USB cable, and the same connection sends sensory data into the computer for processing.
To ensure the smooth control, we average multiple sensor readings to reduce noise. For the MPU6050 sensor, we collected 5 samples, averaged them, applied an offset, and divided by a constant, which is called sense, which converts raw data into smooth mouse movement. For the flex sensor, we averaged readings, triggering a left click when the thumb sensor exceeds the threshold and a right click when the middle finger sensor does too. This ensures reliability in the gesture and the smooth control. The Arduino sends the data to computer as a string with three values: horizontal component Vx, vertical component Vy, and the gesture. For example, it might send something like 3 minus 2 and left click, which means move slightly right and up and perform a left click. Now, on the computer side, a Python script reads this data and uses PyAutoGUI to move the cursor and simulate the clicks. This allows the complete control of the mouse using only the wrist and finger gestures.
The demonstration we see, the VS Code terminal displays the VX and VY and gesture data in the terminal as I move my wrist and controlling the cursor. Bending my index finger triggers the left click, which minimizes the VS Code window. Similarly, the middle finger triggers the right click. This demonstrates how wrist movement and gesture are translated into touch-free mouse control.
Throughout this project, we learned how to interface the MPU6050 gyroscope and flex sensors with Arduino, processing data for reliable outputs. On the hardware side, we focus on sensor integration, calibration, and minimizing noise. On the software side, we applied signal processing techniques like thresholding and smoothing for accuracy and implemented serial communication between the Arduino and PC to enable mouse control via data transfer. This project showcased how technology bridges the gap between the physical and the digital world, improving accessibility for all users. Thank you.